Did you know that when Nikola Tesla looked at the world, he did not see solid objects, static matter, or isolated forms? He saw moving fields of invisible force, streaming, trembling, oscillating in patterns far older than the stars themselves. To him, energy was not merely the fuel of machines. It was the medium of existence, the silent architecture underlying everything you can touch, observe, measure, or imagine. And in a time when most scientists were still debating the nature of electricity as though it were a curious novelty, Tesla was already treating it as a window into the deeper mechanics of the universe. When viewers encounter the idea of energy today, they often think of electricity, light, heat, or motion. But Tesla was aiming at something far more daring. He believed that energy was the language of the cosmos, a kind of universal grammar that shaped the birth of galaxies and the beating of the human heart with equal precision. As Tesla dissected the world through equations, coils, transformers, and high-voltage arcs, he kept returning to a single insight, that the universe behaves more like a vibrating ocean than a static machine. You may picture energy as lines on a graph, but Tesla perceived it as the movement of a boundless field that stretched through all space. When he spoke of frequency, it was not as a technical specification, but as the pulse of existence. And when he referred to vibration, it was not metaphorical. It was the foundational mechanism by which matter organizes itself. Imagine standing in a world where everything resonates, where every structure, stone, air, light, responds to a hidden rhythm. According to Tesla, that is the true world you inhabit, even if your senses cannot yet feel its waves. It becomes clear when retracing his discoveries that Tesla was not interpreting energy as isolated bursts of power. Instead, he was reconstructing the idea of energy into a continuous cosmic medium, a unified field that binds matter and motion, electricity and magnetism, visible form and invisible cause. To understand the motivation behind this reimagining, you must go back to the late 19th century, when Tesla began challenging long-held assumptions about the nature of force. Most engineers focused on what machinery could do. Tesla focused on what the universe was. The alternating current motor, the rotating magnetic field, wireless transmission, these were not technical achievements alone. They were artifacts of a worldview where energy flowed through everything like threads in a vast fabric. Tesla observed a magnetic field rotating. He saw more than the physical spin of machinery. He saw the signature of an underlying cosmic process, energy turning into structure through oscillation. His induction motor was, in essence, an experiment in cooperating with the hidden mechanics of the universe. And if you look at the Wardenclyffe Tower, often misunderstood as a failed ambition, you will find something far more radical. An attempt to plug human civilization into the natural resonances of Earth itself. Tesla believed the planet vibrated like a gigantic conductor, capable of carrying electrical energy across continents through patterns of resonance rather than through wires. To him, the Earth was not a passive sphere. It was a musical instrument waiting to be played. At this point, you may begin to sense why Tesla's ideas often felt too large for his century. His mind was not confined to local phenomena. He saw connections between electrical resonance and cosmic dynamics, between the vibration of atoms and the vibration of celestial bodies. He spoke as though the universe were one continuous field, a sea of oscillating frequencies where everything interacts through patterns of constructive and destructive interference. And while modern field theory had not yet been born, Tesla's language hinted at it decades before physics formalized the concept. Whether he fully grasped what future scientists would later prove remains unclear, but his intuition was unmistakably directed at the idea that space is not empty. It is full, dense with motion, dense with charge, dense with invisible structure. When you think about frequency today, perhaps you imagine radio waves or sound waves, but Tesla imagined something deeper. He imagined a cosmos in which changing frequency changes reality itself. His often quoted idea, if you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. is not merely inspirational rhetoric. It is a condensed version of his entire cosmology. The universe, in Tesla's view, was not static matter, but dynamic fields shaped by oscillation. If matter is energy, and energy is vibration, then the boundaries separating forms are illusions created by differences in frequency. That is why Tesla believed technologies based on resonance could achieve extraordinary results. If you could tune frequency correctly, you could interface with the architecture of nature directly. Wireless energy transmission, remote power, atmospheric electricity, these were expressions of that belief. By the time Tesla began shaping his high-voltage experiments, he had already mentally broken away from classical interpretations of physics. He no longer accepted electricity as a commodity to be transported. To him, electricity was a manifestation of a universal energetic substrate. His experiments with resonant transformers, the Tesla coils, were conducted not merely to create dramatic sparks, but to study how energy behaves when allowed to oscillate freely. Every arc of violet plasma, every humming transformer, every globe of crackling ions served as a miniature model of cosmic processes. These experiments hinted that energy behaves as if it seeks equilibrium across space, radiating, resonating, and redistributing itself with extraordinary precision. Now, imagine yourself observing Tesla in one of those midnight sessions, the laboratory dark except for the luminous streaks of electricity arcing through the air. You would not only witness a man experimenting with engineering principles, you would be witnessing an exploration of universal behavior written in voltage and light. Tesla once stated that the universe is a symphony of alternating currents. To most, this sounded poetic. To him, it was literal. The cosmos, he believed, is driven by oscillation. Planets orbit, electrons spin, waves propagate, fields ripple. Everything moves, everything vibrates, everything participates in a grand energetic continuum. The deeper Tesla went into this worldview, the more he rejected the idea that energy must be manufactured. He believed that energy is everywhere, endlessly circulating, waiting to be harmonized rather than produced. His ideas about extracting energy from ambient fields were not fantasies. They were logical conclusions of his belief that the universe is saturated with motion and charge. If energy permeates the cosmos like a medium, then the question is not how to create energy, but how to interact with it. And yet, this vision, however elegant, left Tesla isolated. The scientific community of his time had not yet developed the conceptual tools to understand a universe shaped by fields and vibrations. His ideas appeared eccentric, unbounded, too vast for practical engineering. But today, with modern physics unfolding layers of quantum fields, vacuum fluctuations, and electromagnetic structures, Tesla's perspective feels strangely prescient. The universe does resemble a continuous medium of fluctuating energies, and the boundaries between matter, space, and force indeed blur under deeper examination. As the narrative unfolds, one question begins to surface for anyone studying Tesla seriously. If energy truly functions as a cosmic medium, what other forces or structures remain invisible simply because human senses have not evolved to detect their frequencies? As Tesla's ideas evolved, the distinction between energy as a measurable quantity and energy as a universal substrate grew increasingly thin. To him, the universe was not composed of isolated parts, but of interconnected oscillations, each influencing the other across vast distances. This concept echoed through his research into resonance, where he demonstrated that a system tuned to the correct frequency could be made to vibrate powerfully with only minimal input. To Tesla, this was not just an engineering curiosity, it was a revelation. If a small pulse could synchronize with a larger system and unlock its stored energy, then perhaps the cosmos itself operated on similar principles, structures amplifying or diminishing one another through harmonic alignment. You might not realize it, but this idea touches the foundation of how waves, fields, and even modern communication systems function. Everything synchronizes, everything responds to resonant force. The Wardenclyffe Tower was more than an attempt to transmit wireless energy. It was Tesla's boldest experiment in testing whether the Earth itself behaved as a conductor embedded in a larger cosmic medium. The tower was designed to vibrate the planet electrically, sending waves through the ground and atmosphere simultaneously. Tesla believed that if Earth's resonant frequency could be harnessed, energy could be distributed to any point on its surface with almost no loss. This was not imagination. It was an attempt to apply resonance on a planetary scale. But behind the engineering stood a deeper vision, the belief that energy connects all things, that the Earth participates in a universal energetic continuum shaped by vibrations passing between celestial bodies. If the planet resonates, then so does the space around it. And if space resonates, then energy is not confined. It is woven into the structure of reality. His critics viewed these ideas as eccentricity. Yet, modern science continues to validate aspects of Tesla's intuition. Electromagnetic fields propagate through space in continuous waves. Quantum fields oscillate even in perfect vacuum. Space is not empty. It is filled with fluctuating energy. And Tesla sensed these truths long before the mathematics existed to describe them. He proposed that electromagnetic energy could move through the Earth's conductive layers the way sound moves through a bell. He believed that the atmosphere could be electrically charged and made to transmit signals or power. These ideas later became foundational for technologies such as radio, radar, and global communication networks. Each relies on the concept that the Earth and its surrounding space can carry oscillating energy across immense distances. Imagine, for a moment, the implications of this worldview. If energy permeates all things, if vibration shapes matter, and if frequency determines form, then the universe becomes less a cold mechanical construct and more an ocean of patterns constantly rearranging themselves. You stand inside that ocean. Your body, your thoughts, the space you occupy, all participate in this larger energetic dance. Tesla believed that understanding these patterns would unlock new forms of technology, allowing humanity to interface directly with the deeper structure of nature. He spoke of machines that could draw power from the environment, of communication systems that required no wires, of engines powered by resonance rather than combustion. And beneath these ideas lay a single principle. Energy is not a commodity. It is a medium, a field, a universal presence. Tesla's experiments with high-frequency currents reinforced this worldview. When he generated currents oscillating at millions of cycles per second, he discovered behaviors unknown to conventional electricity. Light bulbs glowed without wires, metal sheets vibrated under invisible forces, streams of ionized air danced in complex patterns. These were not accidents but manifestations of a new kind of electrical behavior, energy behaving as though space itself were alive with motion. In these shimmering experiments, Tesla believed he was glimpsing the hidden order of the cosmos, where energy travels in waves so subtle that ordinary instruments cannot detect them. And yet, as his discoveries grew more ambitious, the world around him grew less willing to follow. Industrialists sought practical power. Governments sought military advantage. Scientists sought equations that aligned neatly with established theories. Tesla sought the architecture of the universe. His vision demanded a willingness to accept that reality might be shaped by forces far more fluid and dynamic than classical science allowed. To him, electricity was not a technological tool, but the most visible expression of an unseen ocean of energy flowing through all things. His work invited others to question the solidity of matter, the emptiness of space, and the boundaries of what technology could achieve. Consider how Tesla interpreted the relationship between form and frequency. When a system vibrates, its structure can transform. Bridges collapse when forced into resonance. Wine glasses shatter when exposed to particular frequencies. Molecules reconfigure when energized with specific wavelengths. Tesla recognized that frequency was not merely descriptive, it was transformative. Adjust the frequency and you alter the system. Raise it and you energize the structure. Match it and you unlock the system's hidden potential. This principle, which he used to develop his wireless power systems and resonant circuits, also shaped his philosophical understanding of the universe. In his view, Everything is a frequency-dependent expression of a deeper energetic substrate. Change the vibration, and life itself could change. As you reflect on this idea, you may sense how Tesla's thinking diverged from conventional engineering. Most engineers design machines to function within established physical constraints. Tesla sought to design machines that interacted with the invisible architecture of the universe. His coils, transformers, and towers were not mere devices, they were probes reaching for the boundaries of what energy could do. He believed that if humanity learned to cooperate with the natural frequencies of Earth and space, technologies could emerge that would reshape civilization, technologies powered not by fuel, but by the dynamics of the cosmos itself. Yet this vision carried a cost. Tesla's worldview demanded a level of abstraction and intuition that few could follow. He operated at the intersection of science and speculation, mathematics and imagination. And because many of his ideas arrived ahead of their time, they were often misunderstood. But the essence of his thinking persists, the belief that energy is not separate from the universe, but is its defining characteristic, the medium through which all forces travel, all matter forms, and all motion arises. It leaves a question lingering in the air. If energy truly functions as a universal medium, how much of the cosmos remains undetected simply because human instruments are tuned to the wrong frequencies? A problem not of absence, but of spectral blindness? Across the expanding arc of Tesla's work, the notion of energy as a cosmic medium became less a hypothesis and more an operational reality, guiding the way he built machines, interpreted natural patterns, and envisioned humanity's future. As his experiments pushed deeper into high-frequency fields, plasma phenomena, and wireless propagation, he began describing the universe as though it were an immense continuous conductor, one in which all motion, all interaction, all transformation emerged from the interplay of oscillating fields. To observers who witnessed Tesla standing in a storm of electrical discharge, with currents passing harmlessly over his skin while coils roared like mechanical thunder, it was evident that he wasn't simply experimenting with electricity, he was conversing with the underlying structure of nature. And in that conversation, he identified patterns that others dismissed as coincidence, patterns that hinted at a universe where vibration is the root of form. Modern science, with its field theories and quantum frameworks, now edges closer to the realm Tesla sensed intuitively. But Tesla did not need particle accelerators to propose that matter is merely condensed energy, or that space contains invisible fluctuations. He observed these truths in the behavior of circuits, in the resonance of coils, in the propagation of waves through the atmosphere and the earth. His apparatuses were not symbolic demonstrations, they were windows into an unspoken design. When Tesla manipulated frequency, he observed transformations that classical physics struggled to explain. Materials responded in unexpected ways. Currents behaved as if guided by unseen pathways. Waves that should have dissipated remained coherent at great distances. To Tesla, these anomalies were signs that a deeper energetic medium existed beneath familiar physical laws. Consider, for example, his work on electrical lighting without filaments. By applying high-frequency currents to glass bulbs filled with rarefied gases, Tesla produced luminous glows that seemed to arise spontaneously from the interaction between the gas and the ambient electromagnetic field. In these experiments, he saw evidence that energy could be induced directly into matter without direct contact, a phenomenon he believed reflected the same principles that govern cosmic radiance. And while his contemporaries focused on perfecting the incandescent bulb, Tesla was studying light as though it were a natural expression of the universe's vibrational geometry. You stand today in a world lit by fluorescent and LED technologies, both of which reflect principles Tesla uncovered long before physics offered formal explanations. It is here that Tesla's perception splits from that of ordinary inventors. Where others saw separate categories, electricity, magnetism, light, Tesla saw continuity. He envisioned a universe in which all forces emerge from the same foundational substrate, differentiated only by frequency. If you tune into the right frequency, you access a particular manifestation of the underlying energy. If you shift it, you access another. To grasp this worldview is to recognize why Tesla believed wireless power was not merely possible, but inevitable. If the cosmos is already vibrating with energy, and if Earth itself participates in these vibrations, then the challenge is not to generate energy, but to synchronize with it. The difficulty lies not in imagination, but in precision. Tesla understood that resonance is not a metaphor, it is a mathematical relationship. A system responds only when energy is delivered at exactly the right interval. Too high a frequency, and the energy passes through without effect. Too low, and the system remains inert. But hit the correct frequency, and even the smallest input can trigger dramatic amplification. This is why Tesla spent countless hours adjusting coils, condensers, and circuits by minute increments, seeking alignment with the natural frequencies of Earth, the atmosphere, and even the surrounding space. He was not merely tuning instruments, he was probing the invisible harmonic structure of the world. Imagine standing near one of Tesla's giant coils as it emits a rhythmic hum, the air thickening with ionization, the room glowing with purple corona discharges. In that moment, you would feel as though reality itself were trembling. And to Tesla, that sensation was a clue. If a machine can set air, metal, and space vibrating in unison, then perhaps the universe operates on similar synchronizations. He theorized that celestial bodies might communicate through electromagnetic resonance, that planetary movements generate waves capable of influencing distant structures, and that the fabric of space may be permeated with vibrational patterns beyond human detection. These ideas did not arise from mysticism, but from observation. When Tesla detected low-frequency electrical vibrations traveling through the Earth, he concluded that the planet behaved like a conductor wrapped in an atmospheric shell. When he noted that lightning produced electromagnetic waves detectable across vast distances, he declared that Earth possesses natural resonant frequencies, decades before the Schumann resonances were scientifically verified. Every discovery reinforced his conviction that energy behaves like a medium, not merely a measurement. Yet Tesla's insights also raised questions that science has not fully answered. If energy flows through a universal medium, does that imply instantaneous connections between distant points? Could the structure of space allow frequencies to propagate without attenuation? Do hidden modes of vibration exist beyond the electromagnetic spectrum, modes influencing matter, motion, and perhaps even biological systems? These questions unsettled his contemporaries, who feared that such speculations blurred the line between physics and metaphysics. But Tesla saw no such division. To him, the universe was unified, and its divisions were illusions imposed by limited instruments and limited imagination. You may wonder what it means for human progress if Tesla's idea of energy as a cosmic medium is correct. It would suggest that technologies of the future will not rely on fuel, but on synchronization. Machines may draw power from ambient fields. Communication might bypass signals entirely, transmitting through resonant coupling. Space exploration could involve tapping into natural cosmic currents rather than carrying propellant. And if matter itself is structured by vibration, the control of frequency could influence physical form. Tesla's dreams, dismissed as eccentric, may have been early glimpses of possibilities still waiting at the edges of scientific understanding. By the end of his life, Tesla's laboratory was gone, his plans scattered, his devices dismantled or seized. But the principles he uncovered, the resonance of the Earth, the continuity of energy, the vibrational nature of reality, continue to provoke inquiry. Physicists now explore quantum vacuum fluctuations where energy appears spontaneously. Cosmologists examine fields permeating space that influence the expansion of the universe. Engineers study wireless energy transfer once mocked as fantasy. And through all this, the echo of Tesla's worldview persists. It prompts a deeper, unsettling reflection. If energy is indeed the medium of the cosmos, then human science has measured only a narrow band of its possible frequencies, leaving the majority of reality uncharted, undetected, and perhaps fundamentally misunderstood. a technical absence masquerading as certainty.